Hi again. I will be discussing about Newton-Raphson method. Newton-Raphson method is a method of finding successively better approximation to the roots or zeros of a real value function. So, we have here an example function x cubed minus 2x minus 5 equals to 0. We have here an assumption of our xi will be 1.5. So first, you have to get the first derivative of this function, which is, first derivative is 3 times x squared minus 2. So next, you have to get the f of xi, which is by substituting the value of xi in our function. So we will, if we substitute that in our function, we will have negative 4.625, and by getting the first derivative, or f x first derivative of f of xi is equals to 4.75. You get this 4.75 by substituting this xi in our first derivative here. So then solving the xi plus 1 formula. It's the formula for solving xi plus 1. So we have here xi minus f of xi over the first derivative of f of xi. So have here uh, substitute all the values in our formula. So xi plus 1 equals 1.5, which is our xi, minus f of xi is negative 4.625 over the first derivative of the function, which is 4.75. So if you calculate that, we can compute for our xi plus 1, which is xi plus 1 equals 2.4737. So Newton-Raphson is very simple uh, because if we calculate the xi plus 1, we will get the new xi to be substituted in our functions. So we have here our new xi is 2.4737, which is the value of our xi plus 1 while ago. So we have here f of xi. By substituting this new value of xi in our function, we will get negative 5.1831893. Then the first derivative of our function, we will have, by substituting this value of xi in our first derivative, which is 3x squared minus 2, we will have 16.3576. Then we will solve again our xi so that we can get our new xi. So we have here xi plus 1 equals 2.4737, which is our new xi, equals negative 5.1893 f of xi over first derivative, which is 16.3576. This equals to 2.1565. So we have here our new xi again. So have newer xi again, then substitute it in our function. In the first derivative of the function, we will get, first here we will get 0.7158, and first derivative is equals 11.9515. Then we will solve our xi plus 1 again for the last one, equals 2.1565 minus 0.7158 equals 11.9515 is equals to 2.0966. So we will solve our error so that we will know if our assumption is close to the true value. So we have here our formula in solving our error, which is true value minus approximate value over approximate value multiplied by 100. Our true value again will be the previous value, and the approximate value will be the present value. So we have here 1.5 minus 2.4737 over 2.4737 multiplied by 100 is equals to 39.36%. So again, we will compute for our error again. So we have here for our next error, so have here, substitute here our previous error, which is 2.4737 over minus um, 2.1565 over 2.1565 is times 100 is 14.71%. So as you can see, our error becomes smaller. Uh, it 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 means that our value, the value that we are getting in our xi plus 1 uh, is approaching um, is approaching in our two values. It is getting says that says that we are near in our true value. So we have here our third 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 error, which is true value our true value here is 2.15765 minus our xi here, which is 2.0966 over 2.0966 multiplied by 100 is 2.86%. As you can see, this 2.68% says that our assumption here, our computed value of xi plus 1 is approaching nearer in our values. So that's all for Newton-Raphson's method. Thank you.